So today we're on 2.4, day 5. We're doing some more work with inequalities, building on what we did before on day 4. You've done a problem like this in the past, so if you'd like to pause the video and try this problem and then come back, unpause it and just double check that you got it right, and then we can move on to some more difficult examples. But I'm just going to work through this problem here. Determine a few values for x that would make the following inequality true. Can you come up with an interval for all solutions? So just as I would do this with a quadratic equation, I notice that it's a quadratic inequality. I have 0 by itself. I can look at the left side and I notice that it's factorable. So the first thing I want to do here is just factor this left side. And by doing that, what you're recognizing is when we solve for a quadratic equation, we have 0 by itself, and we want to find all values for x that make the left side equal to 0. So by doing this, I note that x plus 3 and x minus 2, as they would normally equal 0 for an equation, in this case, they can actually not equal 0, because if they are equal to 0, then they would make that left side equal to 0, and then that would not be true for our inequality. But these values do help, as we will call them key numbers. So we notice x equals -3 and x equals +2 are going to be our key numbers. And what we're going to notice here is, because it's an inequality, there can be multiple solutions. So if I'm on a number line here, and I have the number -3 and the number 2, well, if I know that the number -3 does not work, and the number 2 does not work, because those two numbers cause my left side to equal 0, then all of these numbers are going to have the same result, either positive or negative, or all of these numbers are going to have the same result as every one in that section, positive or negative, and all of these third section numbers are going to be the same. So what we're going to do here is we're going to set up our interval from -infinity to -3, and again, that has to be a parenthesis, because it's not included our solution set, because it has to be greater than 0. And then -3 to 2, again, both of them as parentheses, be very careful about that. And then from 2 to infinity, again, none of these numbers on the edges of our interval being included. So how do I know if this number, any number in that section, will work? Well, what you can do is you can test any number in this section, and as we mentioned, it would have the same result as all other numbers in that section. So what I like to do is I like to pick a nice easy number, maybe close to that point. So I'm going to test the number -4. Well, if I test the number -4, I can either plug it into the entire inequality, which in this case wouldn't be too bad, but as you end up with larger polynomials, it gets a little bit tedious, especially with no calculator. Or I can plug it into this factored form of that polynomial. The reason being is, if I plug in a -4 plus 3 and a -4 minus 2, because it is factored, all we care about is whether or not it is greater than 0. So when I plug in these numbers, I end up with -1 times -6, and a negative times a negative would be a positive. So because -4 causes the factored form of the left side to be positive, I know that this section is part of my solution set. So this section is going to be shaded and included. Now the easiest number to plug in this middle section is 0, right? Anytime you have a 0 in one of these sections, I recommend that, because it would be pretty easy. 0 plus 3, 0 minus 2. And again, if you use the factored set, it's pretty simple. You have 3 times -2. And again, the end result of the number isn't as important as positive or negative because we have 0 by itself. So because the output is negative, we know that 0 is not in our solution set. And then I think the best number on the right side would be a 3. So 3 plus 3 and 3 minus 2. We have a positive 6 times a positive 1. We end up with positive 6. And again, because it's positive, we know that's part of our solution set. So the interval for this inequality that works would be from negative infinity to negative 3. Be very, very, very careful. And actually, I'm going to put this back in purple. Be very careful because a lot of times mistakes students will make is they'll use their testing number instead of the edge of that interval as their solution. So we have negative infinity to negative 3, union 2 to positive infinity. And so all of the numbers in this interval are solutions. Okay. So moving on to the next example, this one is just laying out the steps. So exactly what we just did up here, we're going to go ahead and do down here. You have it laid out there for you. So if you ever get stuck on a problem, refer back to these steps. We always want to get 0 by itself first. And again, the reason we want to do that is because when we're doing our test points, if we have 0 by itself and we know that the left side has to be less than 0, then when we plug in our numbers, if they become bigger numbers, it doesn't matter what the numbers are. We just have to look if it's positive or negative. And we're going to notice later in this lesson how much that helps when you're using a graph or a calculator to do this. So write the polynomial 0 by itself, find the key numbers. So in this case, we're going to go ahead and factor x plus 8, x minus 4. Because of that, our key numbers, solve for them, would be negative 8 and positive 4. So again, your intervals from least to greatest could be from negative infinity to negative 8. Again, not including negative 8 from negative 8 to 4. And then 4 to infinity. Again, not including any of them. Okay, so those are the intervals between the key numbers, and then we can check the intervals using the positive negative test. And again, this time, we're doing less than 0, so you got to be careful about that. I'm going to use this factored form. So number less than negative 8 would be a negative 9. So if I test negative 9, I would have negative 9 plus 8 times negative 9 minus 4. And again, if you're using the factored form, I have a negative 1 times a negative 13. I just have a positive number. That's not going to work because we're looking for negatives. This is the nice interval. We can use 0, plug it in. 0 plus 8, 0 minus 4. Again, we have a positive 8 times a negative 4, and we end up with a negative number. Doesn't matter what it is, but it's negative, so it's in that solution set. If I test the number 5, 5 plus 8, 5 minus 4, you guessed it, this one is going to be positive, so it's not going to work. So for this one, our solution set is only negative 8 to 4. And again, this is an interval notation, not an ordered pair, because it represents multiple solutions. So as we work on to more practice problems here, this same concept holds. We're going to notice you're finding the key numbers by solving for the left side of the equation. You have 0 by itself, and you just got to solve for the left side of the equation. And those are not your solutions, but rather the key numbers that break apart your number line to find the solution sections. So on this first problem, we have 0 by itself. And now on the left side, if you notice, we can take out a GCF of x. So we have x out in front. And now we have a nice quadratic. And we're lucky in this case because this one is factorable. Now, if it's not factorable, you guys learned on day 1, you reviewed the quadratic formula, which you learned back in Algebra 1 and Algebra 2. So it is possible, and we may do that tomorrow. You have to do the quadratic formula to solve for the other x's. But in this case, it is factorable. So we can go ahead and keep factoring this down to find our key numbers. So now we have our key numbers are 0, negative 6, and negative 7. Now in this case, we have a lot more sections to take a look at. So from least to greatest, negative infinity to negative 7, negative 7 to negative 6, negative 6 to 0, 0 to infinity. And again, all of these are parentheses, not brackets, because there's no or equal to. Now, when we go test these sections, we broke it down on our nice table here. This first one's pretty simple. We just put in a negative 8. So again, when you look at the factored form, makes it a lot easier than doing the x cubed polynomial. We have a negative 8, so it's a negative, times negative 8 plus 6 would be another negative, times a negative 8 plus 7 would be another negative. So we have a negative times a negative times a negative, which ends up with a negative. Since we're looking for something that is greater than 0, this one is not in our solution set. Now, for the next section, we got to find a number between negative 7 and negative 6. Negative 6.5 would fall in that range. Now again, using the factored form, we can find this a lot easier. I have my three sections. Negative 6.5 for x would be a negative number. Negative 6.5 plus 6 would be another negative. And then negative 6.5 plus 7 would be a positive 0.5. This time a negative times a positive would be a positive number. So this would be in my solution set. The next section, I use a negative 1. When I plug that in, I have a negative times a positive times a positive. So we have a negative, which again would not be in our solution set. And then if I use 1 for the last, I have a positive times a positive times a positive. So this would be the other part of our solution set. So our interval notation would be negative 7 to negative 6 and 0 to infinity. The next section, we're going to follow the same pattern, just like the last one. You notice we have a GCF of x. Take out the x, you have 2x squared minus 9x plus 4. And if you didn't do so before, for this problem, you could actually probably pause the video. We just did one similar like this, just a little bit different factoring. If you want to pause the video and try it, you can go ahead and try finishing that one on your own and then unpause it and just double check that you got it. But if you're still struggling, you can keep watching this. Pause it when you have questions, maybe double back. But as we keep going through this, we're going to factor this. And as I mentioned before, this right here is factorable. If it wasn't factorable, we'd have to solve for x another way. But because it is factorable, we can use the guess and check method. 2x minus 1, x minus 4. And again, just like we did before, our key numbers would be 0 if we solved for 2x minus 1. The next key number would be 1/2. And then the final key number would be 4. And again, these are our key numbers. They're not the solutions because it's an inequality. We may have multiple solutions. But one thing to note here, and we're going to talk about this later when we write our final solution, is because it is a greater than or equal to, note that these are actually part of our solutions. In the past, we've said that these key numbers are not part of our solutions. That's why we've had the brackets. So actually we should have made that note up here that x is not equal to. But we had the parentheses because they are not included in our solution set. Down here, because it is or equal to, we will have brackets in our interval notation. So when we go to make our chart, let's break these down. From least to greatest, we have negative infinity to 0. And in that negative infinity to 0, there's a bracket at 0 because it does work. So we know for sure we already have at least 3 solutions. Then we have 0 to 1/2, 1/2 to 4, and then 4 to infinity. Now, when we go to test these points, again, find some test numbers in that section. If I do -1, again, I think the best way to go about it is using the factored form, and we're looking for something that is greater than or equal to 0. So if I have a negative times -3, right? 2 times -1 minus 1 times -5, we end up with a negative. Since we're looking for something greater than 0, that does not work. A number in this set would be a 1/4. So we have a positive 1/4. And then if you need to write it out, you can always write it out in that box, but we have 2 times 1/4 is a 1/2. 1/2 minus 1 is a negative 1/2. And then 1/4 minus 4 would also be another negative. So in this case, we would have a positive output. In the next section, 1/2 to 4, I think a number that would be pretty easy is 1. So if I plug in the 1, I have a positive 1. 2 times 1 minus 1 would be a positive 1. And then 1 minus 4 would be a -3. So we have another negative. And then the last section, if you test 5, we have a positive 5, we have a positive 9, and we have a positive 1. So that would be a 1. So these are our two intervals, 0 to 1/2. Again, be very, very careful. It is very important that you do include brackets when they apply. You do not want to write a parenthesis when that number should be included in our solution set. Okay. Now on the next page, we're on our final couple problems here. When we look at solving inequalities by graphing, if we're solving for this inequality, we just did this on the front side algebraically by factoring and using the key numbers. But if we want to use a graph to solve for this, all we really need are the key numbers. So if we find the key numbers, we can factor this. We have x minus 4 and x plus 3. And we know that those key numbers are 4 and 3, -3. 4 and -3. Well, we're going to go over, and you guys can use your graphing calculator for this. But when you go ahead and plug in y equals x squared minus x minus 12, I'm going to go over to my Desmos because I don't have a graphing calculator on my laptop. And this is what you're going to get. Okay. Now, if we look at our graph, we already talked about on the front side, when you find the key numbers, you're finding the values of x that cause that side to equal 0. So when we look at our graph here, we said that the key numbers were x equals 4 and x equals -3. Well, those key numbers, because 0 is by itself, are the numbers that make the left side equal to 0. So if we look at our graph, those two numbers are our x-intercepts because they cause the output to be 0. So if you have the graph of your left side of your inequality, and if you can see in the top left, I have that inequality, the left side. This is the graph of that left side. So if we go back to our problem, we're looking at the parts on this graph at -3 and 4. You saw on the calculator that this is the general shape. And since we're looking for all of the outputs that are where the y is less than 0, this would be our solution set. So by using the calculator, we can automatically see what the outputs are that we get on our table. And since it's just less than, we know that these have to be parentheses. So our final solution set has to be -3 to 4. And these are all the solutions for this inequality that cause our output to be less than 0. So for the backside, for these next two problems, all we're doing is we're finding the key numbers, and then rather than making that table and plugging in the numbers into the factored parts to find the output, you can use the graph and use the x-intercepts that you already found And just by looking at the graph, you can determine what intervals are on the solution set. Now, obviously, for no calculator, this wouldn't work unless you have a nice graph like this one. Would actually be a pretty nice graph, because it's a positive 1 for the a value, and it's a quadratic. It's going to be left side up, right side up, and so you can kind of sketch out that graph. But for some more complicated graphs, such as number 4, might be a little bit more difficult, or you could probably figure it out, but it might be a little bit easier to use the table and work it out by hand. So if you want, again, if you feel like you're understanding these concepts, you can pause the video for these last 2 problems or for the last one and try it out on your own and then check to see your answers. So for this one, the nice thing is we have 0 already by itself. We know the left side, we're looking for where the x values are causing the left side to be greater than 0. Now it's already factored, so the nice thing about this is we already have our key numbers. We have our key number here is x is not equal to 1/2. We have our other key number, x is not equal to 3/2. And we have our other key number, x is not equal to 5/2. Now again, I'm putting not equal to because it is greater than. It is not or equal to. So again, we can make our table and you can plug them in, or if we're allowed, we can go ahead and type in this graph into our calculator. And if I go back to this Desmos app, and you would be doing it with your TI-84s or 83s, this is the output we get on the graph. Now again, we said our key numbers are 1/2, 3/2, and 5/2. So we have 1/2, we have 3/2, 1.5, and we have 5/2, which is 2.5. And looking at our graph, there's our 1/2, 3/2, 5/2. So this is the general sketch that we have. It goes up, down, up. And again, the exact shape of the graph for what we're doing here doesn't necessarily matter. All we care about is where are the outputs greater than 0. Well, if we look at the graph, that's all the parts above the x-axis. So that is that section and that section. And just from knowing that, we can find our interval notation. So 1/2 to 3/2 and 5/2 to infinity. And those are our solution set. And then in the final part, same concept. This one is also factorable. So if we factor by grouping, we have 0 by itself. Take out x squared, 3x plus 1. Take out -10. We have 3x plus 1. Matching groups, x squared minus 10, 3x plus 1. And then we have our key numbers, x squared equals 10, x equals plus or minus the square root of 10. And again, x equals -1/3. Now again, I'm putting equals because it is less than or equal to. Now, when I go back to my graph, actually, we'll draw a graph here. Mark our key numbers. We should know approximately where square root of 10 is. We know square root of 9 is 3. So 1, 2, 3, square root of 10 would be just past it. And since it is plus or minus, be very careful. We know that it's x cubed, so we know that there should be 3 solutions, and then -1/3 is about right there. So when we look at our graph of this one, that's what our general outline looks like. You can see where it's above and below the x-axis. So if we go ahead and draw this, and again, as we mentioned, we only care about the outputs for what we're doing here. We know all of the portions that are less than or equal to 0. And again, be very careful when you're doing the solution sets that you are clear whether it's a bracket or parentheses. you definitely do not want to have something that looks like this, where it looks like a half bracket, half parenthesis. You need to be clear with your square. That one's actually not great. You need to be clear that it is a bracket or it is a parenthesis. For the infinities and the negative infinities, we always have parentheses. So that's day 5. On the homework, go ahead and work on those. Please be aware if it says no calculator that you do it with a no calculator, because the intention is that you can do them both by hand with that table and with a calculator.